Thank you for joining us for our digital Q&A session with Peter Nikoloff. Before we begin, I would first like to acknowledge that the land that I'm speaking to you from is the traditional land of the Ghana people, and I pay my respects to their elders past, present, and emerging. My name is Sia. I'm one of the space communicators at the Australian Space Discovery Centre, meeting from Adelaide. So we're based out of Adelaide, and the building we're in is actually the official headquarters of the Australian Space Agency. So today in today's session, if you have any questions during our chat, please submit them through the Q&A function, and that way we can pass them on and make sure that those questions get answered. One last piece of housekeeping. So our session will be wrapping up at around 2:45 Australian Central Standard Time. But we do invite you to join us after the event at the Discovery Center or drop us a line via the contact details on our website. So today, our space guest is Peter Nikoloff, joining us from, actually, where are you joining us from today?
I'm at home, actually,
at home,
in my office with all my cool space stuff.
Very nice. You got a very, very compelling background there. So I guess we'll start by a quick introduction to yourself and specifically what it is that you actually do.
Yeah, not a problem at all. So yeah, no, it's great to talk to everyone. So hopefully we've got a lot of very, very enthusiastic space people there, and hopefully younger kids that want to get involved in space and high technology at some stage there. So my background, I started off doing aerospace engineering in Melbourne at the Royal Melbourne Institute of Technology. And the reason I did that was because from the youngest age, I was very passionate. I was very interested in the moon program. So I'm quite old. So all the moon program stuff was relatively new and exciting at the time. So I did my aerospace engineering degree there. And back in those days, half the course was Air Force engineers as well. So I got to meet a lot of people that worked in the Defence Force and doing flight testing. And an interesting fact was one of my RAF members on the course, team friends, was Kath Roberts, who was the first space commander for Australia. And we're still good friends with Kath, and she supports the Andy Thomas Space Foundation. Another part of my passions is helping out with STEM for kids. Yeah, so after I finished my degree in Melbourne, I moved to South Australia and got a job at the Defence Science Technology Organisation. And back then, they still had a lot of the structure and the organisational parts that supported the Woomera rocket range. So I joined the advanced air weapons area and got involved with sort of testing next generation weapons and technology. But that soon sort of linked me back into the Air Force type work, where I moved across and worked with Air Force, as you can see in that picture there, and I transferred to what they call the Aircraft Research and Development Unit. So we used to do all the testing for the Air Force, based out of RAF Base Edinburgh here in South Australia. And my job there was I was the Senior Hornet test engineer, or flight test engineer. So I got to be fully trained up for operations in the F-18 aircraft, so we could support all our various testing. And in that picture you can see there, the missile there was the latest generation missile which the Air Force purchased back in the sort of early 2000s. So it was a British missile, never been flown on F-18s before, so we had to do a whole lot of testing that we could make sure we could operate safely with that new weapon on board. Yep. And there's a couple of big inert bombs as well. And one of the tests we had to do is make sure that the missile and the bomb configuration would not cause problems with normal flight operations, because you get scenarios where when the aerodynamics and the masses of the different items can actually cause some catastrophic aerodynamic things where your wings just fall off, which is not good. So it was a very exciting program working on that one in those early years. But Later on with the F-18 work, we did work not just on new weapons, we had new software loads, there was structural cracking problems we had to fly and test and make sure we can work out how to fix. So there's a full cross-section of really exciting work. But that took us to Woomera rocket range a fair bit. So if you flick back to that first one. If you're not familiar with Woomera, that's the world's biggest land-based test range. Was developed straight after World War II as a result of the German rocket technology and them bombing London during World War II. And so the British needed a big enough test area where they could build their own long-range weapons. And so that's why Woomera was established in the early days. And when they left, that range, rocket range, was taken over by Air Force. So that was one of my tools that I could use when we went out testing. We had all the instrumentation. But that also was a great capability to have, because it really linked us into the very early days of the NASA's moon program. So the moon program, again, for probably those young people that weren't aware, there was 3 big phases of the moon program. So they had the Mercury program, where they launched the first American into space. It was just a single person capsule, and the rocket technologies then were only sort of capable enough to launch very light payloads or light missions. And they hadn't developed their worldwide global network to be able to talk to these first ones. So for the very first orbital flight that NASA launched with John Glenn, the first NASA astronaut that did a full orbit of the Earth, actually went over Woomera, the rocket range, as one of its first places. And so because we had a lot of the instrumentation to support long-range weapons and things like that, we actually provided communications links for NASA. So that picture there shows John Glenn's first path. And we've actually got tracking information, and we've actually got audio. We haven't got it here, but audio of John Glenn speaking through Woomera Australia back to NASA, which is super exciting. So Australia had those very, very first involvement supporting the moon program. So that was a fantastic, and a lot of that old instrumentation, I used to enjoy going out to see that old technology when we do trials out at the Woomera rocket range. Then that progressed. We also, at Woomera, they had one of the Deep Space Network stations as well, at a place called Island Lagoon, but also led to, I think most Australians would probably be aware of the Canberra Deep Space Network. And so now Australia's part of the NASA Jet Propulsion Laboratory Deep Space Network, which is 3 ground stations around the globe, equally placed, so they could communicate as the Earth rotates. As one sort of set, the other one came into view of all the various space probes out there in the solar system. And so, yeah, there's Island Lagoon there. And so, again, Australia was involved at Woomera, and we had sites at Western Australia, but ultimately we're finally in one of the major sites, which is out of Canberra, Timbilla. The other sites are at Spain and in California, so equally spaced around. And now from, I've had sort of good friends working at the Deep Space station out in Timbilla. That's run by the CSIRO, Commonwealth Science and Industrial Research Organisation, which again is a whole lot of fantastic, exciting space jobs for Australians. They get involved with virtually every deep space mission working out in Canberra there. And so if you ever get to visit, I think they still open it up from time to time. You can actually visit the network there. They've got a bit of a museum as well of a lot of the bit of space rock there. Yeah, so that's sort of where my Air Force career moved into working with the range and getting involved with some of these NASA activities. After I finished up testing with the Air Force back in 2000, so that's almost 25 years ago, I then, with the senior Hornet test pilot and myself, we separated from working with Defence and set up our own company called Nova Systems. And one of the reasons we did that was because my friend, the Jim Wally, the senior Hornet test pilot, he was about to be posted and his wife didn't want him to move anymore. Being in the Air Force, you move a lot. So basically, we started a company called Nova Systems. It's just two of us, again, in this little guardhouse at the RAF base Edinburgh in South Australia there. And now that company has grown to almost 900 people across Australia, but also we're in New Zealand and Singapore, in Europe, in Norway, in England, in Ireland. And we do a lot of fantastic work across all different defence platforms. So Army, Navy and Air Force and military satellite communications, we do a lot of support there for the government. But once I'd left, I not only worked with continued working with F-18s helping Air Force, but I got invited back to help run the operations and all the safety for a big Japanese Space Agency program at Woomera. So they were in the process of testing, there you go, supersonic aircraft. And they didn't, again, Japan's tiny and they didn't have big test areas. So they're looking at next generation Concorde technology. And you see that aeroplane, it looks a little bit like a Concorde shape there. But it was basically weighed about 2,000 kilograms, it was 10 meters long, but didn't have any space for propulsion. So they could get it up to test conditions, which was twice the speed of sound, Mach 2, and about 70,000 feet, like twice as high as a normal airliner, where it's more efficient to fly. They brought over their rocket launcher. So that's a Japanese rocket launcher with a huge 5-ton rocket booster on board. And so I worked with the Japanese, lived in the Woomera Desert for about 3.5 months, doing extensive testing before the final launch. So that was super exciting. And the great thing with that program is that they actually donated that launch. They didn't need it anymore. So they donated it back to Australia. And now we do some of our hypersonic research on it. So looking at spacecraft that can fly much faster than this, like 5 times the speed of sound. And so supporting that technology for future space travel and future weapons using hypersonic technologies. So that was a really exciting program to have the Japanese here. And you can see that big shed down the bottom, because the rocket had lots of the aeroplane had lots of instrumentation on, had very fine pressure taps and holes. We had to keep the moist air away so they wouldn't ice up once you got up to altitude, and dust in the holes. So they had this special air conditioned building, which you can see they're working in the building there. And when we got up early in the morning to do the launch, we roll that back, and then the big hydraulic arm would lift up the rocket and point it in the right direction, downrange, and we fired it off. And so that was super exciting. But as with a lot of complex systems and testing, the first launch ended in tears. They had a failure on launch, but that didn't deter them. And we came back a few years later, and the second launch was really successful. So super exciting times and good opportunities for Australian members and our range team to get involved with Japanese trials. So that was one of the exciting projects I got involved with, even after we'd left Defence, but I was like a Defence representative working on that. But from the early days, as I mentioned, my passion was always space. And so a small group of us in South Australia helped out with the South Australian Space Strategy. And one of our first mission was, I was a member of what they call the Space Industry Association of Australia. So I was on the board there. And one of our missions was, let's try and bring the world's biggest congress, space congress, to Australia, to try and encourage the government to set up a space agency here in Australia. So back in 2017, we'd finally won the opportunity to do that. These IACs, astronautical congresses, move around the world regularly, and we're very fortunate to have one coming to Sydney next year. So it's not very often countries get multiple turns, but so in 2017 we actually got the Astronautical Congress come to Adelaide, and we had all the heads of the space agencies. Elon Musk actually came to ours to talk about his Mars missions, and the Australian government actually announced the formation of the Australian Space Agency in 2017, and it kicked off in 2018. So I feel very proud to be part of the people that sort of drove and encouraged the government to actually start a space agency. But in parallel with that, we weren't sure if they'd actually make that big decision in 2017. So my company, Nova Systems and University of South Australia, had another opportunity to try and encourage space activity in Australia. So we bid for a cooperative research centre, which the federal government helps fund with our partners and our universities and industry. And we basically won that bid as well in the same year. It was called the SmartSat Cooperative Research Centre. So that was the biggest space research collaboration the country had ever had. We had like almost 100 partners. We had about $250 million of investment. And so we now got projects all across the country looking at sort of space technologies to help our industry grow. And so that's been super exciting. I think we put through about 70 PhD students. So next generation of space technologists and PhDs, which are really important if we want to keep ahead of the globe with everything there. So that was also really fantastic to be part of that initiative. So they were the two big pillars which we were excited about helping get started from basically support from the South Australian government as well. And the last pillar was, well, with the defence and space sector, there's always a shortage of technologists and specialists to help us with our programs. And so another idea with a small group of us was, well, let's set up an organisation, an educational type foundation, a not-for-profit, that could try and encourage kids to actually go down that STEM path and hopefully build our future workforce. And so I was involved with 3 others and set up the Andy Thomas Space Foundation. And we run programs, we've been going since 2021. We run programs across the whole country to try and inspire young school kids and secondary students and scholarships to actually get into space technology. And just by coincidence, I don't know if you can see my special dress here. We just had our grand final for the Kids in Space program where we got the winners from every state territory. We flew them all into the Space Discovery Centre here in Adelaide, and we had our grand final. And I was one of the judges there, so it was fantastic to see. We had a Tasmanian and a Victorian team that won those won the competitions there, and so they get to visit the Space Discovery Centre. And Enrico, the head of the Space Agency, spoke to him. We had Catherine Bedell-Pregg, Australia's first astronaut trained under the Australian flag. She was speaking to the kids. So yeah, super exciting times. And that program we've put over 10,000, I think 14,000 kids through. So hopefully we get a whole lot of kids that want to come through and work in the high-tech sector. So that's probably a quick overview. I've probably missed lots of stuff. But that's a quick overview of a bit of my career and my passion for space and sort of where I am now, just supporting all these initiatives. And it's lovely to speak to everyone here today on the podcast.
Awesome. Well, that is a honestly fantastic and very fruitful career. Clearly, it's been a lot of really exciting stuff. I guess one thing that I'm definitely curious about is, through this long career that you've had, what are some of the key moments or decisions that definitely shaped the direction that you went in, especially towards the space sector?
I think even though I did my engineering degree at RMIT, aerospace engineering, in Melbourne, actually moving to South Australia because they had the Defence Science Technology Organisation, they had the flight test unit. So I think my passion kept driving me towards where all that exciting space stuff was happening. So don't be afraid to move, not just interstate, but a lot of Australians in the earlier days when we didn't have much of a space industry happening, lots of students actually ended up overseas. Enrico is a very good example. Enrico grew up in Australia. He actually did one of the International Space University courses, which we run the summer program here in South Australia every year. It's about 5 weeks. He actually ran that program, but he ended up overseas working Virgin Galactic and doing some exciting space stuff. But when we started to grow the space interest in the agency in Australia, that brought him back. So we've got all that wealth of international experience coming back as well. So yeah, don't be afraid to go overseas. Catherine Burnell-Pegg, our astronaut, she ended up going overseas and working in Europe on some really cool space stuff. And again, with the agency happening, and she'd started to go through the process of being selected as an astronaut over there. And when she came back, the agency thought, oh, well, that's fantastic. Good inspiration for children. So they funded her to complete her full astronaut training at the European Space Agency Astronaut Training Centre. So yeah, that was don't be afraid to move is probably the big thing, and always reach out to do what you want. So I remember when I started again, space, even aerospace wasn't that big in Australia. The career advisor said, oh, don't do aerospace or don't do aeronautical. There's not much work here. Why don't you do mechanical? There's more, it's jobs in the car sector. And I started first year and I thought, no way. I want to do what I want to do. And so I transferred to aerospace or aeronautical engineering and sort of haven't looked back. It's just been an amazing. So yeah, go with your passion, go with what you really love doing, I think is the important message from that perspective.
Absolutely. It's very, very good good advice, I think, and very insightful. Now, would you say in that process to obviously not only being part of the space sector yourself, but also promoting it within Australia, what were some of the challenges the pivotal challenges that you faced that were definitely the most challenging, and then how did you really overcome those?
Yeah, well, the Australian government really didn't have a strong focus on space for decades, even though back in the Woomera rocket days, we were one of the leaders in putting a satellite in space. There's probably a photo back there of the RESAT. So basically, when the British were here and the Americans came and did a lot of their testing, we had the opportunity. They had a spare ballistic missile rocket, which they handed over to Australia. And they said, look, if you can build a satellite, then we can certainly give you this rocket. And so that was RESAT. There's probably a slide with the RESAT, the little black and white slide there. And so we had, in those early days, we had the Woomera rocket range. That's it there. We had the rocket range. We had the technology. We could actually build, I think we're the fourth country in the world to build a satellite ourselves and launch from our own territory. And so we had that kickstart, but when the British pulled out, the government for some reason was not interested in progressing with all that research and technology and development and train people. So they're the frustrating things that we had. So you got to be persistent with those sort of things. I think that's the important thing. And even up till 2017, the only way you could sort of ensure things would happen is that being persistent. So the Space Industry Association kept doing papers and was speaking to all sorts of people. They had Senate inquiries, and we made sure we had many industry and research people presenting at that Senate inquiry, because that's the government level. They're the things that people actually read. But we really had to try and encourage them to say, look, space isn't just exploration, exciting stuff. It's about supporting our planet. It's Earth observation. It's looking after our environment and waterways and forests. And so there's more to space than just going to Mars and the moon. But that is the super exciting stuff that accelerates technology development and encourages kids to go into science technology. So it's just being persistent from all angles, getting universities to help, industry. So it was really it's been a hard slog for those years, but we've finally got an amazing sector that's starting to grow.
Absolutely. It is definitely flourishing.
Yeah.
And it's really exciting to see how it's growing, not only, with what was already there, but the promotion for young kids, with your Kids in Space Challenge as well, and the different foundations. Now, on the topic of satellites, I guess, I'll move over a little bit to your work as part of the SmartSatCRC. And so earlier this year, you had a very, historic launch with the Kanyini satellite, not only for the Australian space sector, but the South Australian space sector. How was your experience in that, and what were your, what was your role in that project?
Yeah, so that was another exciting one. That project came under the Smart Satellite Cooperative Research Centre, but they're not really, our centre is more focused for the early levels research. So to actually put something in orbit, we actually went back to the Premier at the time, who had a very strong passion. So Stephen Marshall had a strong passion for space. I said, look, really, if you want to help our industry accelerate and grow, so we had a chat to him and said, look, give us a few $1 million and we'll get a satellite up there and we'll get our South Australian industry to build it. And he actually said yes. So that sort of grew out of that. And then we, as SmartSat, we managed the overall mission and had some great companies, Myriota, South Australian company, and Innovor, both based at Lot 14 with SmartSatCRC, and Nova Systems helped out with some technical advice and support. We're spread across the country. So that's where I've sort of got involved with that. But being a very experienced engineer with various space activities in the past and complex systems, I think I was the logical person to make the mission director. So basically making together, we pull together all the team, and as we go along designing and developing, make sure it's tested properly and solving problems along the way. So it's really been an exciting pathway, a tough one. It's not easy building something that goes into space, but really it's the, I think we've got a good slide up there now, really that earlier generation of satellites were only could be afforded by governments basically, and they were the size of buses, and launches were super expensive. But as technology reduced and launch costs came down, it now became viable where small research programs and universities and industry can actually now build satellites and get involved with the global space sector. So the Kanyini satellite is those 2 loaves of bread, the one at the end there of the slide pictures. So we've got 2 loaves of bread. We've got a couple of solar panels that fold out, and we've got 2 main payloads. One of them was built here in Adelaide, like by Myriota, so it can do very sophisticated advanced communications with the Internet of Things technology. So it can talk using its advanced communications technologies, talk to very, very small items on the ground. Now, only small packets of information, but they can talk to anywhere on the globe, basically. So a good example where this works with small volumes of information is helping out cattle stations and sheep stations. So they're huge. Some of those stations are almost as big as England. And they've got to work out how they can monitor effectively all the water supplies and the windmills and make sure the animals have all got drinking water. Now, traditionally, they'd drive around the ranges, the stations regularly, and that would take lots of time and destroy vehicles. Whereas Myriota had this technology where they could put a water level detector on the tanks all over their station, and they could send up using very small instruments with battery lives of up to 3 years, send the information up to satellite, and the farmers get it all on their app. So they no longer have to go out every time. They only go out when they detect a problem. So this is where a very low-cost, high-tech solution from Australia actually can really help them, because traditional satellite technology is very, very difficult. Well, that's a picture of some of the South Australian industry that are involved with building these satellites. So on the left there, you got Innovor that actually built our satellite, and you got their teams of engineers in their clean room suits. Because a lot of if you've got optical sensors, you can't afford to get any dust in there and things like that. And Flavia is another from Fleet Technologies, another South Australian company involved with those projects. But yeah, it takes systems engineers and design engineers to actually build and pull these things together, because they're complex. Everything has to operate with everything else. The comms have to work with the Earth observation, with the thermal management and the power management and the navigation systems that point them in the right direction. So yeah, it's not hard. It's not easy to put that into the size of 2 loaves of bread.
Absolutely.
So yeah, and a lot of that was built here in Lot 14, which is super exciting. And we also had an Earth observation payload, which we got out of Europe. It was the latest technology, what they call hyperspectral sensor. So we can look at light over 50 different bands, which really gives you so much more information when you're analysing crops and things like that.
Awesome.
So that's a bit of the Kanyini story. Oh, and
Yeah,
also
yeah,
the other thing with that is
yeah.
because the other sensor was developed under funding from the European Space Agency, we're now actually doing research programs. So it's given us a connection into the European Space Agency, looking at the latest technologies in AI, artificial intelligence processing of space data in space. So yeah.
Absolutely. So I guess based off this, what do you think is the next horizon? What's the next big thing for the Australian space sector?
Well, it's really, there's a whole lot of research and technology happening in our industry across the country. And the agency is really helping out with one of those. So they're funding a lunar rover, which you might have heard about. They had a competition, and this rover, which we've got two teams looking at the initial designs, and they've submitted them to the agency, and the winner will design the actual rover. It'll be about 20 kilos, and NASA will deliver that to the moon for us. And so that's also some very exciting work that's happening. It's be away about 20 kilos. And also it brings together some of the other expertise we have in Australia. So Australia leads the world with remote mining and autonomous systems mining. So we've got some of those organisations involved with the design of this rover. So it's this advanced technology we do on Earth, which is going to help us in space. And the aim of the rover is to be part of the, I guess, support the research and development of how we sustain a base on another planet. And the start will be Moon. NASA wants to set up a permanent moon base where they can test the technologies, get resources, dig up the ice and turn it into water and electrolysis to split that into oxygen and hydrogen, so you can use it as fuel. So it's all part of that initial work to build long-term bases on the moon and Mars. And to have Australia involved with that is super exciting. But if you look at some of those other pictures, the hypersonic research, future travel, if you can travel at greater than 5 times the speed of sound, you won't have to sit on planes for 20 hours. Well, actually, I went over to a conference in Alabama last week, and that's where NASA built the moon rockets at Huntsville. So I got to see a full Saturn V standing up. But basically, be able to travel there instead of that took 4 flights in 32 hours. To be able to go hypersonic and do it in a couple of hours would be so cool. So Australia's getting involved with that sort of research through the universities, and now Defence are looking at some of that research. Space tourism's another big one that's starting to pop up, and hopefully in time that'll become affordable, and Australia may be a base where they do this sort of work here. And the other ones, advanced sensors, we're doing a lot of research in that area. Kanyini with its Earth observation, communications. Defence need a lot of next generation technology if they want reliable, resilient communications to support various operations. So a lot of those things are activities happening in Australia.
Absolutely. Now, I guess as being one of the big change makers within the Australian space sector, what changes would you like to see? Do you think there's still, obviously there's always work to do, but is there anything specific that you think can definitely be a big change in the future for Australia?
Well, one of the big things we're really trying to encourage is we need to have more sovereign Australian-owned technologies, because space technologies are so important. And if you don't own or control it, you could easily lose access to it if other countries are busy, or wars happen and they not. We've got a good start. We've got a lot of small companies, but I think the civil space sector, the federal government needs to invest more in Australian technologies. So that's one of the things we're continually trying to encourage. And with COVID, people saw when you had problems with supply chains and getting access to technology, even it's just making masks and medicines and things like that, having to rely on it, wait for it from overseas is always a big challenge. So the more we can do in Australia is really important. And the same with defence. Defence over the next decade will be spending probably $10 billion plus on new space technologies. But because the threat is coming up so quickly, they've got less time to actually incorporate Australian industry, but they should still actually work on that. So we're really encouraging Defence again to invest in our local industry as well. Even though we can't do the big big systems, but there's still elements that we can provide niche technologies and experience to support. So yeah, they're the areas trying to build our sovereign, build our Australian capabilities is really important. A lot of that is the people to start with.
Absolutely. Now, before we quickly go to the Q&A, I just had one more question. I guess myself and I'm sure a lot of the viewers would also be wondering, you've had such a long and fruitful career in the space industry. What are some skills or some steps or any big advice that you give to someone trying to get into the industry themselves?
Well, it just depends on what areas they want to get into. So I really enjoyed designing and getting involved with complex systems. So having a good sound engineering degree and I guess learning the skills and the things you need to understand how you operate and build systems. So systems engineering, which brings together all the pieces of the puzzle, it actually helps you go through a rigorous process. So working out what your requirements are, what's your mission need to really required to succeed, then going through those preliminary designs and trade-offs, and then going through the actual final design and testing and building all the parts that need to support that. Like you need, if you've got a mission in space, you need the ground stations to support it. You need to be able to train your people. So that's what I'm passionate about. So systems engineering and looking at the big picture design. But we also need the specialists. So if you're really passionate about, advanced communications, go to that next level, do some masters or PhD and get those skills that sort of places ahead of the rest of the world. Same with Earth observation. There's so many skills there in data analytics. People don't realize that a lot of the money we make in the space sector comes from the processing and the ground data that we actually utilize and turning it into something that can help, help farmers and crops working out how much fertilizer they need, whether it's good water, whether it's disease. So there's so many different areas. And so if you're really into those specific areas, get in and maybe go a little bit further with your studies and do masters and PhDs and become world leaders is another area. But yeah, there's so many areas of interest, but you've got to find something you're really passionate about, I think is important.
Absolutely. Thank you. Now, we've got a couple of questions from the Q&A. So firstly, what challenges have you identified in space propulsion?
Space propulsion is really hard, as most people know. And if we're looking at the future, if we're doing deep space activities or maintaining satellites in stable orbits, electric propulsion is really the way of the future there, because you don't need to take chemicals up. They can operate for much longer periods. I guess the advantage with them is they're not high power, high thrust type activities, but if you want long-term sustainable activity, then they're the way to go. And so there's even a company in Lot 14 working on this electronic propulsion type technology. So that's one area that maybe in Australia we could become really good at and support sort of spacecraft up there. But the other big challenge globally is getting to Mars and going to the moon. As you can see, the rockets are huge and the amount of fuel you need, and it's just a massive big overhead. And to try and get to Mars quickly, for example, you need to build massive rockets. And at the moment, even with the best rocket technology and combinations of fuel, it still could take you 6 months at least to get to Mars or more. And the problem with that is the radiation. You're spending all that time where you're not really well protected. Until you get to Mars, you can build shelters with protection. And so I know that it's starting to pop up these days. They're looking at nuclear propulsion, where you could cut that travel down, way down to maybe a third of the time or less, and make traveling to other planets a lot more viable and safer for everyone. So yeah, nuclear propulsion, electric propulsion, I think are the two areas which I think are worth looking at.
Awesome. Now on that as well, bit of an interesting topic, I think, recently, especially on the mission to Mars. Do you think, I guess, also from your background in defense, you would have seen it in aircraft, but do you think in-flight refueling for spacecraft is going to be something that will pop up around as well?
Oh, you've been doing your research. You know that's already happening. It's starting to do the research. So no, yeah, definitely. So again, because of the sheer amount of fuel you need to get to Mars, I know SpaceX are certainly looking at with their super large rockets that they're building at the moment, the Starship. Um, one of them, even though they're massive, the biggest rockets of the day, they're still not going to have enough fuel to get. Once you get into orbit, you've burnt up most of your fuel. So they are literally looking at sending a second Starship up, docking and refueling so that spaceship can go further. And you probably need multiple missions to actually build the rockets and the infrastructure you need to get to Mars. So yeah, in-flight refueling hasn't really been done before on a serious scale like that. But that's also very important. I've talked about some of the older generation bus-sized satellites, which do amazing work for our communications and GPS systems and things like that. But they cost billions, and when they get to the end of life, often they're quite long, 10 or 15 years, but you don't want to throw them away. And the only reason they become unusable is because they run out of fuel to maintain their orbits. And so they're now looking at how they can refuel some of those older spacecraft and sort of kick them back up to a good orbit if they've slowly drifting out of it. So refueling is going to be important. So all future large type satellites will probably typically have the ability to just plug and refuel really easily. And again, another company in Australia is looking at space servicing. The Space Machines Company want to build a spacecraft that can go up maybe with a SpaceX mission, take some of these little CubeSats, move them into better orbits, and then ultimately head out there and refuel some of these other spacecraft which are getting old or moving them to different orbits. So all that technology is happening as we live. We're actually in that age where all these next generation of space technologies are really starting to flourish.
Absolutely. Now, I could go on a tangent about in-orbit infrastructure with you all day, but I think we only have time for one last question from our audience, and that is, do you have any role models or anyone in your personal life that inspired you to pursue the career that you have?
Well, as I mentioned there, I grew up through the Apollo area. When I went to university, obviously Apollo had been finished, but I used to go down to the library and they didn't have internet. They used to have little film rolls, and I used to go and watch all the film rolls of the engineers testing things. But Gene Kranz, who was one of the mission directors for NASA during the Apollo program, and if you watch some of these movies like Apollo 13, he was the guy that pulled together the team to do the rescue when Apollo 13 blew up. But people like that, and obviously the astronauts of those early Apollo days were really, a lot of them were engineers as well as test pilots, actually. Most of them, I think they were all test pilots, the very first generation. They're the people that really inspired me to get involved with flight testing and space and things like that. So that era, they really did amazing activities.
Absolutely. Well, thank you for your interview today. That is unfortunately all we have time for today, but it has been an extremely insightful and very, very interesting chat with you. So thank you so much, Peter, for joining us and sharing your story with us. It's been absolutely fantastic. For our viewers, if you would like to learn more about space in Australia or how to become space experts or follow a career like Peter's, please come visit us at the Australian Space Discovery Centre. But yeah, thank you very much.